Okay, so we're going to go ahead and get started here. As promised, day 4 is going to be relatively light on slides compared to other days when we cover. We're going to cover a few examples of different debugging tactics, problems that can occur, and review some previous cases we have seen in the past with various interesting issues. After that, we will have catch-up time on the labs for any labs you guys don't have done yet, and I'll hang around to help you get through those labs to make sure everyone's able to go through and do the Ansible and AVD work. So, what can go wrong when we're using Ansible? Like we've mentioned before in this, because we start layering so much abstraction onto the problem area when we're dealing with Ansible and AVD, it's very wide to troubleshoot compared to what you might be used to when working at just a single device level with usual attack cases. Ansible playbooks usually are going to span, at the very least, a subset of your overall DC fabric, and they can cover the entire DC or even multiple DCs, depending on how the customer scopes things. So when you work with Ansible issues, it's very important that you aggressively scope down the problem in the beginning. The smaller you can make the search radius, the better. So some things I'll commonly do are I'll ask a customer, okay, did this playbook previously work? Do you have outputs and runs to show me? Can I look at your Git history? Have you made changes and I can see in your Git logs that might indicate where the problem would be? If I diff your current playbook into your Git repository, what's different about it you haven't committed yet? Things like that. That gives me some very good early indicators as to what they may have changed. It could be inventory files, it could be plays they've modified, it could be additional configs, invocations, things of that sort. And we'll get into some examples after this. You also want to verify that they're using the right credentials. In all the labs we've shown you so far, all the devices had the same credentials, and we've always given you the right credentials. That's not always the case with customers. There's two things you'll see happen. One is that some customers use per device passwords. While we don't recommend that for most customers that are using things like CloudVision, some people still do this for various quote unquote security reasons, and they won't use AAA. We'll also see scenarios where they're using something called the Ansible Vault, and we'll touch on that briefly, to store the passwords so they aren't exposed to any of the files they have in Ansible. That is okay. The problem can be in two different parts. One, they might store the wrong value, and you can't visually tell if their password or username is wrong because it's been encrypted that way. The other is that sometimes the Ansible playbooks you're using will not support the use of vaulted credentials, and that can cause its own problem. You also want to verify that your connection type is what you expect. As we've talked about in previous days, we support two different ways to connect to EOS devices. There's the old school network CLI way, where we log in by SSH and scrape the screen and give output back. And then there is the HTTP API way, which is our preferred and recommended way to do it. And that's where Ansible actually talk to the EOS API to get responses back. And finally, if all else fails, turn to verbosity, just look for CP or anything else, and start reading through logs. So, high verbosity runs are one of my favorite things to grab when customers claim a playbook having an issue. Like you've seen by this point, Ansible commands, in this case Ansible playbook, have a number of different flags you can set. Tags you've seen before is point several times, and this is fairly straightforward. The V flags are something you haven't seen in the labs before, but if you've ever used other Linux tools, it's the same concept. In Linux, for most tools, there is a convention of a V flag, and that's for verbosity. When you specify the V flag multiple times, it becomes increasingly verbose. Most tools will have at least 1 or 2 levels of verbosity. Some have up to 4 or 5. For Ansible, I usually like to set 3 V flags, which gets extremely explicit and just let it run and dump to a file. When you run something like that playbook you had yesterday at triple verbosity, you'll start seeing outputs like this, and it will tell you a lot about what's going on behind the scenes. So if you're looking to break down the magic wall of what an Ansible task or playbook is doing, high verbosity is the way to go. Like you're seeing here, when I start an invocation, it's going to start printing out what config file I'm using to even load the inventory, everything else. It'll show me all my different callbacks I'm using and how I'm parsing my inventory. It'll show me the inventory I'm using. It'll look at any callbacks I registered to do different kinds of handling. It'll dump out details about the playbook I'm running, all the plays in there, any kind of handlers they're using. And then for each task, you'll start seeing the task will also dump incredibly verbose logs. So what you'll see here, this task is where we are creating the output directories. You'll see the actual connection where Ansible is doing SSH to localhost, and then it's executing the commands to actually build the directories and set up the permission mask. You can see all of that. You'll also see where Ansible is storing the temporary script files it uses to run on a given host if your playbook is using that as well. There is about 10 pages of output you get from this run that I can't show here just because it'd be unreadable otherwise as a slide. But if you run this in your topology, you'll see what I'm talking about. Similarly, if I was to take off my build tag here, use the deployment tag, you would see details of all the API calls that are being made to devices and to CloudVision. The CVP collection also has the ability to dump a debug log. This is different from the example I showed you in a previous slide because it is not in line with the output of the playbook execution. It actually will create a separate file that someone could then upload to either a GitHub issue or to a attack case. As you can see here, it's a little different than you might expect. The way it currently works for that CVP collection is it asks you to build and source a shell script that then affects how the Ansible collection for CVP will run. This is a little weird and it's not Ansible-y. So if any of you are looking for a project to get your feet with and contribute to the CVP collection, this would be a good place to start. Ideally, what you'd want to do is just convert this system to something where you would expose vars on a play with the CVP collection and write the file that way, instead of having to source a shell script. The main thing with something like this is that this is not conducive to debugging in containers or as part of a CI/CD pipeline. Like if someone was to deploy network changes via a trigger when they commit to their GitHub repo, which some people do. Also, something that comes into play when you're trying to figure out why something breaks is variable debugging. We've talked about some on different days, but when it looks like something's not working expected, first things we want to verify, of course, is that one, our host of the variables we expect, and two, we have the inventory graph we expect. So standard procedures, you can use that Ansible host debug command I've shown here to dump all of the outputs for a given host. And then the Ansible inventory command here will give you the graph of all devices. Questions on these tools so far? All right, sounds good. So another thing you have to check is that your collections are up to date. Ansible code is like any other language in that when you write it, it can have bugs. Our code has had bugs in the past for our different collections. We've had issues with how we do search keys for devices in CVP. For a while, we would say that the default was FQDN. It was actually hostname. We've had issues with how we parse the ZTP updates for the collection, things of that sort. So one of the things that we'll do when we are looking at a customer's issues and what they're reporting with a playbook is we'll also ask them to give us the Ansible Galaxy collections list for their environment so we can see what version our collections are on. If they're on Arista.cvp version 2, for example, we know they're going to have an issue with ZTP. So if you're doing ZTP operations failing, first thing I'm going to do, upgrade the collection. There's other fun bugs we've had as well. I'm not going to go over all of them here, but in general, if you're looking to see if the customer's behavior is due to a collection and not their actual playbook actions, look at their GitHub repositories for the various projects, look at their issues there, and see if it has been fixed or if it's still extant. Vaulted credentials. We mentioned these earlier. These are a fun little feature of Ansible to try and help people avoid committing sensitive files to Git or keeping the local files. What happens is you feed Vault this concept they have called a vault file, and it uses that to either encrypt files you have in your Ansible directory or single values. So for example, if you consider your usernames and passwords sensitive, you could vault both those. So then in your playbooks and your inventory files, you would just see these blobs of gibberish for both username and password. You could encrypt the entire inventory file if you wanted to, things of that sort. When a user does this and they go to run a playbook with vaulted values, Ansible will prompt them to unlock their vault by providing the password value or an identity file for the vault file. And that's then used to actually decrypt and use the actual vault credential contents. You have to make sure the collections in use support vaulted values. It's not guaranteed because these aren't just strings. Under the hood, they can also be dictionaries of a certain kind. And if a collection does not know how to handle that, it can barf. Case in point, before Ansible, before Arista CP 3.4, we didn't support the use of vaulted variables for talking to CloudVision, and it would just give you a 401 back. If you're suspecting a problem with vaulted values, you have to work the customer to get decrypted outputs of those so you can actually do debugging. Very similar to when we're looking at TACX issues with the customer, and we have to have them give us their TACX keys to decrypt Wireshark captures and verify those. Obviously, if they don't trust you, that puts a roadblock on things, but then we can also put it back on them. Again, same as if we're trying to decrypt radius for TACX traffic. So what I put together here on these next two slides is just examples of various kinds of Ansible and AVD cases we've seen in the past that have some more interesting problems than just running a playbook. One of my more memorable recent cases was with Zoom, where they had a number of things wrong in their environment. So for those of you who have not seen Zoom use Ansible or AVD ever, the way to use it currently is extremely customized. What they do is they have a set of Ansible files per data center, so one directory each, and they don't run it directly from their local system. What they do is they bundle those files into a container image, and they run all Ansible jobs from that container image. This creates a few fun issues. Number one, they have to make sure they're editing the right set of files. In the past, they've done things like edited the files for a DC on the East Coast, and then asked us why the changes weren't reflected in the DC on the West Coast. Because unlike an environment where they might use different groups in inventory to do that, they have separate environments for each DC entirely. So we have to make sure they actually write and use the same set of files for the environment they're in. They've also written bad Docker files before that would explicitly pull in old versions of our collections. And so because of that, it's a little harder to fix than just doing a Galaxy update. When we're in our usual environment, we can do Galaxy update. We'll update the collection, it's good to go. Because a Docker file builds in the immutable image, we actually have to take the Docker file and validate it works as expected with them, things like that. They also, because of that Docker file issue mentioned, they were pulling in a dev branch that we had merged 6 months ago, because originally they were trying to work on a CTP bug when the 3.0 collection was not released yet. So they had never updated their Docker files before we had merged that code. And so they were pulling in old and buggy code still, things like that. So when you see some of these cases, it's not always just about troubleshooting Ansible. It can also be about troubleshooting the environment around Ansible. And that's where things can get kind of tricky in what we will and won't support. Not even just Arista versus non-Arista products, but also between what division it is. We helped out here some on this, but with the level of customization done by the US Plus team and the PS team for this, we also had the PS team do a number of different testing and Docker file changes for them. But nonetheless, it's an interesting case to look at. Next case I have listed here was also a Zoom case, and this was specific to how they actually run their Ansible playbooks. Like we mentioned, they run them in Docker files, which build containers, and they run those. So what we discovered is that they opened this case reporting that they couldn't talk to CVP from Ansible. They were suspecting a database issue. What it turned out is that when they were stopping and then restarting their Docker containers on the deployment host in question, the host the containers were running on would never re-inject firewall rules to allow the communication. So all the API calls from Ansible would die at the host because the firewall on the host would block communications outbound, things like that. Again, we have to really look at the entire environment we're looking at Ansible cases, not just the playbook itself. After we discovered that, we haven't fixed the firewall, everything was fine. This last case on this slide here goes back to what I've been saying about vaulted credentials. This one was an exciting one where the customer opened a case with us saying that after they upgraded to a certain version of EOS, Ansible stopped working. Now, that's not supposed to happen. And I did a number of repros in the lab to prove that I couldn't get that to happen and everything was fine. We did extensive high verbosity debugging in the customer environment, and we believed we had traced it down to an issue with their TACX server sending a banner with characters that the network CLI connection type could not parse and causing it to exit. What we ended up finding out was that in their inventory, they were using vaulted credentials. And for one device, the device in question they upgraded, the password in the vault was wrong. And that's what's causing the issue. Unfortunately, we didn't catch up sometime in our testing because we never bothered decrypting the vaulted credentials. We were just testing with unencrypted credentials on the command line, and those tests were passing. So lessons learned from that: decrypt early, decrypt often, and don't trust vault. More fun, continuing our theme of screen scraping not being effective. This first case here is one that is fairly recent. And what happened here is that a customer had upgraded their EOS version and was discovering that then afterwards their config pushes had broken. Relevant to this is that they were pushing TCAM profiles when they were doing their playbooks. One of the things that happened with that is in newer versions, when they do a TCAM push, the CLI would print a warning message back. That warning message was just similar enough to what a prompt looks like that it would confuse the Ansible network CLI screen scraper, and it would think it was getting a command. So it would see the extra data was given, get confused, and hang up. That's an issue, unfortunately, with the Red Hat Ansible implementation, so we couldn't fix it. That's on Red Hat to fix. What we did tell the customer to do in this case was to switch the connection to HTTP API. Basically, instead of SSHing in and making it screen scrape, talk to API on the device and do your changes that way. And that did work for the customer then, because like you saw on day one, when we're using our eAPI, it's that loosely typed JSON RPC schema, and we can read that and parse it for just the results. And the warnings are a separate key, so it won't confuse our logic. Finally, this last one here is really recent, and this goes back to what I mentioned with support for vaulted variables. ASU recently had a case where they were trying to use vaulted credentials for CVP, and it wasn't working. They were using an older version of the CVP collection, and it didn't support vaulted creds. So for that, fix there is one of two things. Either they can upgrade to fixed collection version, or they can stop using vaulted credentials. But these 5 examples here show you some idea of what kind of flavor you can see with Ansible and AVD cases. In general, although we sometimes get requests for things like updating a playbook with custom schema to extend a VLAN or something like that for a customer, we won't do that. even if TAC was to support AVD and Ansible for our products, we wouldn't handle something like that because it's a design level issue. You saw some yesterday with how we took down ETH1 and ETH6, how those custom structured config keys can work. But changes like that aren't a break fix. Those are typically a design change at the fabric layer. So that would still be out of scope for us in such a future state. So with that, that's our quick and dirty troubleshooting presentation examples. Now we're back to lab time. Like we discussed, today is going to be wrap up. Any questions you have in labs you've done so far, I'll be glad to answer. If you're stuck on any labs, I'll help you get through those. And then what we're going to ask as well is just you can fill out a really short form again, just a post survey about the course. Tell us what you thought, what you would change, and that'll be it. Thanks, everyone.